Unit 6, Section 4, rhombi and squares. Rhombi is the plural of rhombus. Rhombus, that's plural. We can put R-H-O-M-B-U-S, singular. Put plural. Plural. There we go. Rhombi, more than one of them. One of them is a rhombus. Okay. Rhombi or a rhombus has the same properties as parallelograms. It's a parallelogram. It's just more specific. It's more specific than, well, that's different specific to a rectangle. I would have done rhombus first, then rectangle, then square probably, maybe. But rhombi have all of the things of parallelograms. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other, and all four sides are congruent. So whereas a rectangle, opposite sides are congruent, in a rhombus, all sides are congruent. Perpendicular. All diagonals are perpendicular, and the diagonals bisect each other. Okay. So the diagonals are at 90 degrees, so that's something good to know. The diagonals bisect each other. That means they cut each other exactly in half, so that's also good to know. So let's see how we can apply these extra rules for rhombuses. So all the rules of parallelograms, opposite sides congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles supplementary, diagonals bisect each other. I don't know why we had to list that on number. Oh, here we go. Dissect, not each other. So if we do that, cancel that. Diagonals bisect opposite angles. Read the wrong thing. There we go. Diagonals bisect opposite angles. So not only do the diagonals bisect each other in length, they cut the angle that they run into in half. So that is very important. We know that either side is going to be equal. Where like on the rectangle, either side wasn't necessarily equal. Okay. So let's look at a rhombus. We know that JK is 12. And we know that JN is 7. And since we know opposite sides are congruent, we know that's 12. And since we know the diagonals bisect each other, we know that part is 7. So we need to find the missing measures. Well, JM we don't know yet. JL we can do. That's 14. Oop, messed that up. MN we don't know yet because we don't know that diagonal piece. But MK, we also don't know that yet. So we're going to have to figure something out. We need a piece, right? We need to be able to figure out a piece. Oh, actually, you know what? All the sides are congruent. So not only is this side and that side, but this side and that side. So we know that's a 12 and that's a 12. So we can put 12 here. Look at that. Read the rules. Okay. Now, what we can do is figure out the total length of MK, this piece right here, because we're going to use, not in that one, but we can get half of it by doing just this piece, because we know that these are at 90, and if we do this triangle, we can do a squared plus b squared equals c squared. So if we have this little triangle, and that part's 12, and this part's 7, what's that part? Well, that's 7 squared plus x squared equals 12 squared. Or 49 plus x squared equals 144 minus 49. So x squared equals 49. Nope, not 49. Hello. 144 minus 49. Doink. which is 95. And I'm going to go ahead while I'm already in my calculator. About 9.8. So if we square root both sides, the opposite of square is square root. The opposite of cube is cube root. The opposite of fourth is fourth root. So if you want to undo square, like when we do divide to undo multiply, and we do subtract to undo add, you're going to square root to undo square. So x equals about, squiggly, 9.8. So we know that mn is about 9.8. We go squiggly, 9.8. And if we double that, it's going to be squiggly. Let's see, 9.8 times 2, doink, 19.5 it looks like. It'd probably be 19.6 if we actually did it. Let's see, 9.8 plus 9.8. Look at the difference when we round. For y equals fraction if 19.6. So rounding versus not rounding. Like if I round it and then I add it, and then if I don't round it and I multiply it by 2, I get 19.49, which would be 19.5. But if I round it to 9.8, I add together, I get 19.6. Goodness. So let's do 19.6. Let's say that one. So we'll do 19.6. We got them in. Oh, they rounded down to 9.7. Yeah, I guess that's more right. There we go. So let's look at that. So we go 7, 4. There we go. Nerds. 7. Okay. Better rounding. Hello. Let's go ahead and try number 2. Pause it, and then come back and let's see what you get. Okay, here we go. EF's 23. That means this one's 23, and that one's 23, and that one's 23. And that is a box. Okay. DF is 40, so that means this is 20, and that's 20. Let's find the pieces. G to F, 23. H to F, 20. G to H, we don't know yet. G to E, we don't know yet. We got to double it. It's the same deal. We got a little triangle here. We don't know the bottom, but we know the back is 20, and we know the hypotenuse is 23. That's a right triangle. So 20 squared plus x squared equals 23 squared. 500 plus x squared equals, I don't know what 23 squared is. Let's see. Clear. 23 squared is 529. 529 minus 500. So we subtract 400 from both sides. So x squared equals 129 square root. X equals the square root of 129. 11.4. Approximately 11.4. So this piece is 11.4. So if we double it, that's 22.8. And we got them. All right, let's look at this little guy. Another one just like it. RT, all the way across is 22, so that's 11, and that's 11. And US is 18, so that's 9, and that's 9. What we don't know is the far side, but remember that's a square in there. Those are all 90s, so if we go one side's 11, one side's 9, we don't know this one. So 11 squared plus 9 squared equals x squared, or c squared. That technically could be c side. You could say c. 121 plus 81 equals c squared. That'd be what, 202 equals c squared, square root. And c is almost, we're going to have to need the square root part first. Square root 202. 14.2. So v to t is 11. U to v is a 9. R to s is a 14.2. And then s to t is also a 14.2 because all the sides are the same. They're congruent. Let's check out some angles. Okay. Well, we know that this one's 90. And that one's 90, and that one's 90, and that one's 90. That one's 38, so is this one. I'll do that little mark. You're 38 because they bisect. And opposite angles are congruent, so we know this is 38 and that is 38. Now, let's see. Let's put some of these bad boys down. We don't know 1 and 2 yet, but number 3 was 38 degrees. Number 4 is 38 degrees. Number 5 is 38 degrees. Number 6 and 7 we don't have yet. Number 8 was 90. Now, how can we find the last one? Well, we know that 180 minus those other two is what one of them is. So let's say 180 minus 90. That's the easy one. It's 90. Minus 38 equals 52 degrees. So that means you're 52, and you're 52, and you're 52, and you're 52. So that's 52 degrees, 52 degrees, 52 degrees, 52 degrees. Got to find them and fill in the blanks. That's all you got to do. Number 5's got sides and degrees in it. I already know that this is 90 degrees, and that's 90 degrees, and that's 90 degrees, and that's 90 degrees. Z, X, Y, Z to X to Y is 34. So I know you're 34. That means you're 34, and you're 34. So let's see, what's 90 minus 34? It's 56. 56, 56, 56. What do we got on distance? Z to Y is 34, so all of these are 34. And WY is 38, which would be 19. So where's, let's see, the one we don't know is 34, 19. What's the back? So a squared plus 19 squared equals 34 squared. A squared plus 19 squared, that's 49. 19 squared, 361 equals 34 squared. 1156 minus 361. So a minus 361, both sides. A squared equals 795. Square root. A equals the square root of 795. 28.2 approximately. Keep recording. Okay, good. 28.2 is what we figured that out to be. So that's 28.2. So Z to V is 28.2. WZ, 34. V to Y is 19. Z to X, 28.2 twice. So let's see, 28.2 times 2. 56.4. Angle measured WX Z. Didn't they just tell us ZX? Oh, they did Y. So 34. And WV, doesn't matter, it's going to be 90. And ZY, W is 56. That's how we figured it out to be. Yep. And XY, W is also 56. There you go. All of the parts. Part 2. Let's talk about squares. A square is a special type of quadrilateral that is a parallelogram, that is a rectangle, that is a rhombus. Then it is also a square. It's got all of the bits of everybody. Okay, square has all the properties of a parallelogram, a rectangle, and a rhombus. All the opposite sides are congruent. All the opposite sides are parallel. All the angles, opposite angles are congruent. Consecutive angles are supplementary. The diagonals bisect each other. It has 4 right angles in the corners. The diagonals are congruent. 4 congruent sides. The diagonals are perpendicular. The diagonals bisect opposite angles. All of that stuff is true of squares. So Memorize the lists, and let's put it to work. If ABCD is a square and AD equals 11, A to D is 11. That means this is 11. That means that is 11. That means that is 11. Find each missing value. Well, we know that these all have to be the same. And we know that these are 90 degrees. So I've got 90 degrees. This is 11. And technically it's A and A. Or X and X, because the sides are the same. It's not X, it's not A and B, because they're not two different sized sides. They're the same size. So I have A squared plus A squared equals C squared, which is 2A squared equals C squared. And my C squared is 11. So I'm going to figure that out. Right there. Tell you what. So let's see what we get. Because they worked it differently. But 11 squared is 121. 2A squared equals 121. And we're going to divide by 2. So A squared equals 121. 2 equals. Of course. Let's do that. Well, it'll be 0.5, right? So if we do fraction decimal, 60.5. Square root. A is approximately. So what is the square root of 60.5? Okay, so we got 7.78, so 7.8 is what we'll say. 7.8 approximately is that tiny little piece in there. So if this is 7.8, then this is 7.8, and this is 7.8, and this is 7.8. So be about 15.6 all the way across. So from B to C, it's 11. From A to C, it is 15.6, 7.8 and 7.8. From B to D, it is also 15.6. From E to C, it is 7.8. That is a weird 7. There we go. The measure of angle DAB. Well, D to A to B, that corner, 90 degrees. AEB, that corner, 90 degrees. CBD, well, this cuts in half, and if it is a 90 and this is half, that's going to be 45 degrees. And from B to A to C, again, half of 90 is going to be 45 degrees. Go ahead and try number 7. Give it a pause, come back, let's see how it goes. All right, it's a square. TR is 17. So that means this is 17, and that is 17, and that is 17. Find all of the missing values. Well, we don't know side C, but we got 17 squared plus 17 squared equals C squared. Or you could say 2 times 17 squared equals C squared. So let's do 17 squared times 2. So 578 equals C squared, square root. C is approximately the square root of 578. 24.0. And we're going to do it to the 0.0 because we've been rounding the whole time to one decimal place. So I'm going to keep that going. Even though my decimal is a 0, it's significant. I know I rounded to that spot. So I'm going to include it whenever I put my answers. So this is 24.0, and this is 24.0, and this is 24.0, and this is 24.0. So from P to R is 34, it's 2 17ths. From Q to S is also 34, it's 2 17ths. From Q to T is 17. From P to Q is 24.0, approximately. P, R, S. Well, it bisects that angle, and that angle is a 90-degree corner, so we got, that's the wrong button, 45 degrees. S to T to R is 90. Those diagonals intersect at 90. PSR is also 45 because it's a half C. And QPR is also a 45 because it's a half C. If MNOP is a rhombus, find MP. So we got 2 rhombus questions and 2 square questions left in the section. I'll do one, you do one, and then C. I'll do one, you do one, then C. So we just have to find MP. We're throwing in the algebra. The MP is this one. So if it's a rhombus, then all the sides are the same. So that means that this side is equal to that side. And subtract 3x. 6x minus 77 equals 7. Add 77. 6x equals 84 divided by 6. X equals, let's check 84 divided by 6 is 14. Do we find x or do we plug it in? Find MP. I got to plug it in. So 3 times 14 plus 7. 30 and 12 is 42 plus 7 equals 49. So MP equals 49. Number 9 is about angles, it looks like, but same ideas. Use those rules about rhombus. Give it a try. Come back. Let's see how you did. Okay, here we go. The diagonals bisect the angles, so that means that 8x minus 20 equals 5x plus 1 minus 5x. 3x minus 20 equals 1. Add 20. 3x equals 21. Divide by 3. X is 7. I don't need to find x. I need to plug it in. I want to know F, E, D. Well, what I need is angle CFE, the whole thing. So if I have the whole thing, I can do consecutive angles or supplementary. So let's plug this in. 5 times 7 plus 1 is 35 plus 1, which is 36, which means this is 36. And 36 plus 36 is 72. And 180 minus, that's supposed to be a 7, is 108. So that means, hello. This is 72. 180 minus 72 equals 108. This is 108. So that's 108 degrees. Yeah. Squares are even more specific on the rules. Like a rhombus is all the sides are the same, the diagonals bisect each other, and the angles that they touch. But now we put in all of the rules of, well, the middles are 90, and the middles are 90, and the middles are 90, and the insides are 90, and the corners are 90, and all the 90s. So if STUV is a square, with SW being 2x plus 13, and WU being 8x minus 41, find V all the way to T. Well, V to T is going to be the same as S to U, and I just need the parts. And those parts are equal. So 8x minus 41 is equal to 2x plus 3 minus 2x. Let me just algebra real quick. 6x minus 41 equals 3. Add 41. 6x equals 44. Is that right? Did I write it down right? Oh, is it a 3? Nope, it's a 13. There we go. Plus eraser, U, pencil, 54. There we go. How did I know? Because it's going to be a decimal, and I don't expect a decimal unless I'm told to round, so it doesn't go into 44, but it will go into 54. So easy way to check your work. X equals 9. Do we find x or do we find something else? No, we got to plug it in. So 2 times 9 plus 13. 18 plus 13 is 28. 29, 30, it's 31. So if this one's 31 and that one's 31, and this one's 31 and that one's 31, which makes it 62. Wow. Kind of circled that right through there. There we go. So go ahead and give it a pause. Let's put your brain together, see if you can do number 11, and then come back and let's see how it works. All right. Solve for x. Oh, all we got to do is find x. So that's cool. Well, I know that that little corner is a 90, and I know that that's a half a 90, which is 45, so 7x plus 3 equals 45 degrees. Minus 3, 7x equals 42, divide by 7, x equals 6. Solve for x. I did. Bing, bang, boom. That's all there is to it. The hardest part about all of these quadrilaterals is memorizing the rules for what they are. What makes it a parallelogram? What makes it a rectangle? What makes it a rhombus? What makes it a square? What are the increasing amounts of rules for them that shrinks what they are and gives them a specific name?